Hello, Kraków. How are you? Great, okay. Infrastructure as a code describing infrastructure, but it has to be stored somewhere. And in Ocado, we have GitLab. And resiliency of GitLab instance for our business is a bit critical. So, at first I talk a few words about who we are, then why we are here, some background of GitLab internals to better understand what we meet on our way to some improvements in our GitLab. Then, of course, deployment, problems we run into, once again deployment, some aftermatch, and a bit time for Q&A. So who we are? We already know Paweł introduced Ocado Technology. So who I am? I was a student when I started working in IT as sysop. Maybe someone knows acronym BOFH. Anybody? Ooh, much younger audience. Then in 2016, I chose the light side of power, so switch to DevOps Engineer. And in 2020, I joined Ocado Technology and a team which is responsible for GitLab instance in Ocado. I'm a family guy, interested in 3D printing and also radio amateur enthusiast, so Sierra Quebec 6, Oscar Whiskey Hotel from this side. GitLab advertises itself as a from planning to production tool. So we have some support for organizing teams, tasks, of course, source code repository, then CI pipelines, etc. Everybody should be familiar with Git. Who has met GitLab before? Okay, who has the opportunity to administer some GitLab instance? Ooh. So, it's very popular software, especially because there is some community or better open source component. So it's free for use and scales from everything in single container with 2 gigabytes of RAM to multi-node installation available from cloud vendors, available as self-hosted instances, but also provided as a service by GitLab itself. There are some free tiers, paid tiers. Everything can be found on gitlab.com. And we are using GitLab in Ocado. It's self-host, self-managed instance. It's hosted on AWS. And we are using infrastructure as code approach, but we keep going on AWS CDK still. Some statistics, about 3,000 active users, 43,000 projects, about 100 kilo pipelines a day, so quite heavy load on our GitLab runners, terabyte of source code and few terabyte, about 80 terabytes of other assets like artifacts or large file storage for GitLab, for Git. So why you are here? It's third-party software, pretty common. What we could talk about? It already works. Our instance in more or less this shape dates back to 2016. So I was just starting my DevOps engineer career. My colleagues built this instance. It's critical asset for our company. As every development company, we have to store our source code. Our developers has to be able to pull it, modify, and push back to the repositories. We want such system to be available all the time, especially when company grows and our development teams are spread from nearly Japan just to United States, so across a globe. And we also want it to be kept up to date, of course, for security reasons. And there is no way we can schedule a maintenance break in a way that everybody is happy. Our maintenance break on Monday night was exactly at the time when our colleagues from United States finished their lunch and want to continue their work. We also want our system to be reliable, and reliability in our approach is something more than we can rewind to last backup made last night, or even snapshots a few hours later, because it will introduce some disruption to our service with a deployment time of about 2 hours. And when reaching backups on cold storage in AWS, it's more like 12 hours. So can we improve our setup? Before we dive into it, we have to get some idea how GitLab works with source code storage. So GitLab is simple application, Ruby on Rails one, with some services running across multiple nodes. And here is diagram borrowed from official documentation. For our orientation, Puma, Workhorse, GitLab Pages, and GitLab Shell are services facing our user. So, graphical user interface, serving repositories, etc. There is Sidekick, background job processor. So when we make some schedules, it will work on executing them on time. And there is Gitaly, our main actor today, repository storage service. We have those infrastructure deployed into AWS. So we have Sidekick, pretty nice auto-scaling group with about 16 instances. Then frontend with a load balancer in front of it with 6 to 25 instances depending on the load with dynamic auto-scaling. And 2 Gitaly nodes because one was not sufficient in the terms of the bandwidth. And they are implemented as a single member auto-scaling groups with persistent storage. It's a bit hacky way to make those instances unsyncable. And of course, there are some services that are accompanying those installations. From a GitLab point of view, repository storage is organized into shards, but the documentation doesn't hesitate to call them storages. And each shard is served by some Gitaly nodes. Same shard can be served by 2 or more Gitaly nodes. And each repository resides only in one shard at the time, but there is no problem to move them around between storages. GitLab has nice requirement to have default storage, of course, and there is no problem if it's only just as a placeholder and not used anymore. It must exist. So, Gitaly, we see nice Gopher, so Golang is here. Main reason is that Git was not designed to be accessed by multiple instances at the time. So, GitLab goes into way of creating gRPC service to provide Git repositories to the rest of GitLab. Data is stored as bare Git repositories. Anybody knows what's this? One. So if we check out repository from Git server, we get working copy and a small directory called .git. This directory contains all the objects from our repository, and it's exactly bare Git repository. So it's Git repository which don't contain working copy in it, just objects, references, etc. Most operations on storage are performed using bundled Git, and it's usually mainstream Git. GitLab contributes to it to get some features for its purpose. Usually is most recent version available. A single Gitaly node may serve multiple shards, so multiple storages from a GitLab point of view. And there is a way to combine multiple Gitaly nodes into a single shard using software called Prefect. Prefect acts as a proxy which stands between GitLab and Gitaly nodes and translates those shards laying on Gitaly nodes as a single shard offered to GitLab. From GitLab point of view, it's transparent, but to manage the state of the repositories, it employs some Postgres database, and main configuring parameter for Prefect is replication factor. Anybody familiar with Cassandra DB? Oh, quite many. So, in Cassandra DB, the same parameter is used to tell how many copies of each object that in database has to be stored on different nodes. In a case of Gitaly cluster, we can say that we want each repository to be kept on 2 replicas, so on 2 different storages or shards. So, can it help us? We could use several nodes for data redundancy, so if one is not available, the another will serve our repositories. Okay. There is a reconciliation mechanism in place, so when one shard is not available for one Gitaly node is not available for a while, it should synchronize nicely when it's back online. Okay. So it makes us able to shut down the node, replace AMI to the new version, and start it again, resynchronize it, and zero downtime for our users. Of course, there is some drawback, increased complexity. So, how it will look in our case. Sidekick queue and frontend are not affected by our changes, but on your right side, there is prefect and 3 Gitaly nodes in place of 2 Gitaly nodes before. Prefect works as a 3 instances in autoscaling group to keep them alive, and there is a load balancer in front of them to split the traffic. Of course, there is some database to keep state. So, we show this architecture to the GitLab guys. Okay, you are free to go. So, let's introduce Gitaly cluster to our instance. At first, it's about November 2022. Plan was really simple. Add cluster to the infrastructure as code definitions. Deploy new infrastructure over existing one. Perform migration, measuring most vital parameters to prepare our users to things that will have to come on production. Then prepare those communication, deploy changes in production environment. So far it's straight transparent to our users. Perform migration, it should be transparent to our users. Some cleanup, and of course, celebrate. What could go wrong? We cloned our production environment to the staging one, run migrations, and at some point they stalled. We try to migrate remaining projects, errors on the console. At this point, some repositories got broken. It smells nasty. We can't clone them. We don't see them in GitLab UI, just great place where files should be. Errors in Gitaly logs shows there are missing objects. And git fsck says, sorry, not this time. So it smells very, very bad. On production instance, those repositories are okay. So we assume cloning goes as usual, so no problems expected here. Something must be wrong with our new Gitaly cluster. Missing objects exist in a production instance, but not in repositories itself. There is something more which is called pull repositories. That's interesting. So time to dive deeper what's in GitLab and how it actually stores repository data in Gitaly. From a developer point of view, how we imagine a repository. Chain of commits. Commit after commit after commit after commit. Of course, sometimes there are forks, merges, etc. But chain of commits. From storage point of view, there is blob with some objects. Those objects are not necessarily connected with commits in a straightforward way. So, when we fork a repository, we create exact copy of those objects. After fork is created, those two repositories live as a parallel worlds. They contain some set of common objects, and new developments are held in them. It's not storage efficient, and storage is a bit expensive. So, taking one step back, people from storage knows something like deduplication. So, let's do it with our repositories. Let's move all the common objects to the separate pull repository and replace them with a pointer in main repository where to look for it. And all required mechanisms are in place. GitLab has, Git itself has mechanism of alternates, which contains file system paths where to look for objects that are not found in a repository itself. Nice. So, when forked repositories are living as parallel worlds, we keep only changes, and those common objects are kept only once. Many projects run fork way of working that when we create fork, introduce our changes, and they are merged to the repository, to the main repository. It's pretty common, so for some repositories we have 40 forks or even more. So this mechanism is very storage effective. GitLab has to maintain pull repositories, it's obvious. And there are some assumptions made to make it working. The main and most restricting is pull repository, and all related repositories have to be stored in same storage shard. Alternates contains file system paths, they must be on same file system. Nothing extraordinary. And there was a design decision that the duplication of forked repository will not be available. So we can fork repository multiple times, but fork of the fork is not supported. GitLab stores information on pull repositories in its database. And it smells fishy because there is no mechanism in place to keep database state coherent with storage state. Gitaly operates on repositories using simple Git, which of course support alternates. And GitLab, who manages pull repositories, clears orphaned pulled repositories. They are just deleted. At the moment, then GitLab no longer thinks they are in use. They are in use according to its database. And removal of fork relationship, as well as move of storage between repository between storages, implies reduplication. Those objects from pull repository are copied into original repository, and the alternates file is deleted. What could go wrong in that scenario? We found several unofficial forks. Git repository on Gitaly storage still has pointer to the pull repository, but GitLab doesn't recognize this state as valid. So some information was lost, taking to the account that over 7-year-old instance with multiple migrations behind, some storage structure migrations. It could happen. Don't blame GitLab. But we found something just more interesting, chained pull repositories. For some reason, some pull repositories also contained alternates. So we have repository which indicates to the pull repository that indicates to another pull repository. What GitLab does during reduplication, took those objects, copied this to the repository, and removed alternates. As long as we operated on repository with Git, those chained repositories are perfectly okay. But reduplication mechanism doesn't support this. So we have to flatten such chains, of course manually. It wasn't hurting because it's about 15 chains per 43,000 repositories, so not very problem. Then copy pull repositories into safe place, just to make them backup. Force reduplication for each project. And GitLab has no problem that we try to reduplicate project which, according to GitLab database, is not deduplicated. And if we encounter some errors, so pull repositories disappear during reduplication, we just copy missing pull repositories in place and again force reduplication. When we are clear of errors, repositories are in state that allows us to move. So back to our test on staging. We did some improvements, added 2 more steps to our migration plan. Can we proceed? It works, expected, but it works very slow. About 2 repositories a minute or even slower. So having to migrate 43,000 repositories, it's a bit time consuming. But we found a bottleneck. Scheduling repository storage moved was way too slow. So who's responsible for scheduling move? Of course, Sidekick. So let's add another Sidekick node. It will its just sole purpose will be to perform migrations. It's not very resource-consuming activity, so give it 64 threads to do it, and all repositories were moved into hours. Nice! So, with big enthusiasm, let's go to production. We warned our users there will be some migration, but don't worry, it will be fast, will not affect you. Of course, there is implementation plan, more detailed, with some safeguards like at first we will migrate some volunteers to test if everything's were okay. After bake time, we migrate other projects, then do some cleanups. Okay. Our architecture of choice assumed 3 nodes, 2 terabytes of storage for each, 3 perfect nodes in auto-scaling group, some AWS RDS as database, network load balancer in front of prefect nodes, replication factor of 2, because we don't want overpay for storage. Testing with early adopters, so how to find volunteers in a software development company. Our team was first. We move projects one by one because we have to filter out all other projects. So we employed some scripting with Python over GitLab API. Each repository migrated in few seconds. Nice. We intended baking time of 2 weeks. And after a week, we were on the previous storage again. For some reason, forking repositories makes them not being able to replicate anymore. This time we were on production. This time we were pretty sure that we did everything okay. So we called for help. GitLab, we got a problem. It took about 2 weeks to figure out what happens. They try to reproduce our infrastructure, they try to do some nasty things as well as we, and we find it. Replication factor. As I said before, we are using some deduplication to conserve storage space. So how it works with GitLab and Gitaly. GitLab tells to create fork repository. GitLab tells Gitaly to create pull repository. Then link source repository to the pull. And link forked repository to the pull. 4 easy steps. And in case of standalone Gitaly node, everything happens on the single file system. Everything is in place. What happens in cluster? We have our repository, primary and secondary replica, on 2 nodes out of 3. Then we create fork repository. Prefect has rolled the dice and choose 2 nodes out of 3. Then created pull repository, and then try to link source repository to the pull repository on the node when pull repository was missing. And there is no way to tell prefect that, you know, but there is a replica for that repository, and here you get a replica of pull repository. So it's stuck in the state, and there is no way to go forward. So GitLab revised its documentation. We revise our cluster, change replication factor to 3, and try to go to production once again. Once again, 2 weeks of baking time, everything works okay. So let's move all the repositories. It was about last Thursday in the June when we tried to do it. We divided our move into 2 batches, so about 21,000 repositories to move in each batch. We choose to migrate them one short source shard at the time. Execute migration for the first shard, and users started reporting repositories switched to read-only. Some first people who noticed this are on this in this room. So, what's happened on our production? It took about 4 hours to GitLab to stabilize. We can't undo step we initiated at this time. If repositories are scheduled for move, they are switched to read-only, just to GitLab not taking care about future changes until move is complete. Half of our repositories for the time of about 4 hours were unavailable to development teams. So it's great disturbance. We postponed second part, and started looking for what's happened. Any idea? What's the main difference between cloned production as a stage? In most cases, there is one small difference: traffic. If we have production instance and we are doing migration during working hours, those Gitaly nodes will be loaded with traffic from our users. Pretty strong sidekick cluster, scheduled move for all 20,000 repositories in about 5 minutes. And then started with the struggling with a move with some help of big repositories. So the second batch was moved next day. This time we were pretty conservative. We started with about 100 repositories, then increased gradually to 1,000 repositories at a time. Strictly monitoring stress of the storage nodes, monitoring queries lengths, and keeping it more or less under control. But a few teams were affected once more. Why? 200 gigabytes plus repositories. If you ask somebody if there is something you shouldn't put into your Git repository, what it would be? Binary data. Executables, AMI images, and images at all. So, for us, it was a great opportunity for a promotion of LFS, large file storage for Git. It helped many teams with their day-to-day work. And now we are 5 months later. Gitaly cluster is working most of the time. When it stops working, we have to kick with a hammer to recover replication. We are working with GitLab, so there are some tickets from us and currently solved in GitLab. Edge cases like forking fork, disconnecting it, and making fork again. We haven't met data loss so far, but even if our replication fails, it fails for single repositories. So before, when one Gitaly node falls, we lost half of our repositories, about 21,000, and need some long time to recover from backups. Now, No data loss so far, and very small blast radius in case of failure. GitLab provides some metrics, but none of them allows us to find stored replication. So we do it by foot, but working on some automation to keep replication working for us. No downtime upgrades usually work, and usually because sometimes GitLab don't handle properly DB migrations, but last times we did few shortcuts too much. So procedure of GitLab upgrade must be followed very strictly. And would we recommend it? If you run GitLab for small team in container, it's much cheaper to do frequent backups than utilize 6 more instances to keep Gitaly cluster running. But if you run in a large company and have to keep it running all the time and have team who can care on it, it works. With some struggles, but it works. So that's all from me. I'm open to questions. Do you have any?
Do we need a mic somewhere? Yeah. So that it gets recorded. Oh, maybe it doesn't anyway.
Hi, I'm Piotr. Thank you for the very interesting presentation. I have a quick question to the point you said about your infrastructure, like you have 25 auto-scale up to 25 instances of on the front-end side. And my question is if you are able to share some insights on how big the traffic is, how many users you have, how many stress the environment has to endure. Thank you.
At this moment, we don't have slides with this traffic. Usually, read rate on Gitaly replicas are approaching 140 gigabytes per second, as I remember. Megabytes per second. Gigabits, megabytes. So it's high traffic, and before we have to employ second Gitaly node to spread the load between 2 nodes because traffic was so big that storage nodes doesn't do everything on time.